All right, let's get rolling. While we wait for everyone except the 3 people that are here. If you're watching this, you might not be one of them. All right, so I asked you to watch a couple videos. Your mileage may vary on how that all went. I probably ought to get the lights on up here. So in those videos, first off, let's just like keep reviewing these basic derivative. That's lovely theme music. Basic derivative formulas. We still aren't really to the hard part yet. The hard part is this thing called the chain rule. And when we get there, that will actually be that's a big leap from these basic formulas, but we still have to get these basic rhythms understood. So in terms of just a function, if I've got this, I bring the exponent out in front, diminished by 1. There's a couple special cases you should keep in here. So the derivative of a constant, what is that? What's the derivative of a constant? Well, I'm sorry, what?
Is it a constant?
It is a constant. It's a special constant.
0?
0. Always think back to derivative is tangent slope. If this is the constant and we're always there, my slope is 0. So the derivative is 0. So another nice one to just have at hand is that the derivative of some multiple of x is just that number out in front. These happen all the time. Good to just have them quickly handy. And then that's about it. I don't think we've had any other rules yet except the ones I gave you. So let's enter those today. The derivative of e to the x is the easiest thing in the world. What is it? E to the x. Hell yeah. Exactly. Awesome. E to the x. That's just one of the greatest, simplest math facts in the world, right? Just copy the problem down and you got it right. And then this one's a little trickier. The inverse of e is the natural log. What is that derivative?
1 over x.
1 over x, quite beautiful. Yep. And there's a few domains here. This would be, we can actually write this a couple of ways. This is if x is greater than 0. I don't think we'll encounter this, but just in case we do, the derivative of the absolute value of x is also 1 over x, which is kind of cool. And that's just as long as x isn't 0, where natural log isn't defined. So we got these basic rules too. Now, for combining things, we've got the sum difference rules. So let's get those up here. You see, I do now. There we go. There we go. So combining derivatives. These are kind of special meta rules. So if I have the derivative of a multiple c times some function f of x, I just pull that c out in front. I think everybody knows that. Notice here I'm using multiple notation styles. That prime just means ddx, derivative. We also know that if I have the sum or difference of 2 different expressions, I'm going to put plus minus here, that is the sum or difference, depending on what that is, of the things at hand. The derivative of a sum is the sum of the derivatives. The derivative of a difference is the difference of the derivatives. And now we've got 2 new ones today. This is what we're going to spend today on. We'll probably have to come back and practice this on Wednesday quite a bit. So this one has got a special name. This is called the product rule. And we're going to work with it a little bit. I'll explain, I think on Wednesday, I'll give you an intuitive idea of why this is the case. But if I have the derivative of f of x times g of x, and I'm gonna ask you to start doing something weird. especially if this becomes troublesome, read the expressions to yourself in your mind. And if you say times or multiplied by, then this rule is at hand. So the way this works is it's not the product of the derivatives. Right up here, the derivative of the sum was the sum of the derivatives. Not true here. In this case, each derivative, each piece of the product gets its derivative, and I leave the other pieces alone. So first I take the derivative of this expression times this one untouched, plus then I leave the first one alone times the second one, its derivative. This can be expanded to bigger products, but let's just work on two for a little bit today. And then we have another one called the quotient rule. This one's a lot trickier. It's a little bit similar to that one, and you're going to want to reference this a lot. The derivative of f of x divided by g of x. So I've got an expression where there's division, which you'll see a division bar, is the derivative of the top times the bottom left alone. So far it's looking like that, except now I've got a minus. And it's now just the top times the derivative of the bottom. So the top of this looks like the product rule, but it's got a minus in it. So the order in which I take derivatives is super important. And then this is all over the denominator square. Oh, excuse me, that should say g of x. So whatever this denominator is, I just square it. And literally by putting bracket, parenthesis, whatever, squared. So look at the rhythm here. It is derivative of the top times the bottom minus top times the derivative of the bottom. All over the bottom square. Good way to write it. When I first took out my first calculus class, Calc 1 was taught by this like gajillion-year-old lady from Kentucky. She had a wonderful Kentucky accent. And she said something like, she would sing this out, D high, high D, I don't even know what she was saying. It's not, I can't even remember, it didn't help me. It was like high D low minus low D high over, D, I don't know what it was. It sounded great, never did a damn thing for me. This is what we're going to work with today. Things get challenging when these start getting combined in the same problem. So let's start off with a chill example. I want to take the derivative of x squared times e to the x. Notice how I said that, at a times. So this is a product. So to do this, I'll do the first one. And another thing, write out. Use the notation to keep your bookkeeping. You've all taken accounting. Do the accounting here. So the accounting is, I'm going to write out what needs to happen until I become an expert at it. So I still need to take the derivative of x squared, but I'm going to leave e to the x alone. Plus, now I'm going to leave the x squared alone. And even though I already know that this is just the same thing, I'm going to write it out for today. Yes, ma'am?
What rule is this one? Or what is this?
Well, you tell me. Let's talk. It's good stuff. I like that question, Hannah.
Okay. I don't know the answer.
Okay, well, let's see it. So read this expression to me.
Derivative of x squared to the derivative of x squared to ex.
Say it with what is operation in the middle?
Times ex.
Yeah, so it's a product.
Product, sure.
So I use the product rule.
Okay.
Okay, so let me put that up here until, I wasn't trying to give you a hard time.
I didn't know if it was an example or if it was another rule.
No, oh yeah, I see what you're saying. Yeah. We're just working with product rule and quotient rule today. So everything will be one of those two.
Okay.
Then I go through and do the derivatives. When I see this symbol, it reminds me, hey, I haven't done the bookkeeping on that yet. So now, what's the derivative of x squared?
Two x.
Beautiful. How do we all feel about that? Pull the 2 out in front, 2 goes to a 1. We don't write the 1. I'll put it there for right now. Times e to the x, I don't need to do that derivative. Plus x squared times, Louisa, what's the derivative of e to the x?
E to the x.
Beautiful, we're done. Nice, thank you. Pretty sweet. Nice little rhythm. Calc is all about these rhythms. If you wanted to get fancy, what could you do with this algebraically with some parentheses? Think factor out. What could I factor out? How is this? This is in common to both terms.
Yeah.
What else could I pull out?
And x.
X, beautiful. I'll put that in front. And then I'm left with
2 plus x.
2, beautiful, 2 plus x, nice. That's the kind of thing we're going to want to do eventually. Sound okay? Yeah, cool. So let's do some more. This one's for you. Please find the derivative of square root of x times the natural log of x. What rule are we going to use? Product, because I said times. Product rule. So use the product rule first. Want to convert square root of x to the 1/2. Let her into the restroom. I'll be right back. Good morning.
Good morning.
Let's come see what's going on here. How's it going, Louisa? What you thinking? Let's see. So I love that it's missing its x.
Oh.
Yeah, everything else looks fantastic. So, you didn't actually take the derivative.
Oh, shoot.
Do you see what I mean?
Yeah.
So yeah, I think I've seen this happen to you before.
Yeah, yeah.
So maybe just write ddx there in front of that one and then do it, but otherwise that looks great.
Okay.
How's it going, Jack? Oh, I like how you did that. Can you simplify it a little bit more?
Yeah.
Yeah, nice. Just another heads up, now that we've increased by 33%, we have a 33% increase in attendance, so this is great. The MyOpenMath, still just don't worry about it, okay? We'll come back to it. It's kind of a good review after we've gotten through a bunch. It's literally all of differentiation, and most of it won't make a lot of sense until after we've gotten to that point. Cool, so first thing I do, and I love to see your notation on this, first thing I do is write out this. I'm gonna put parentheses here so I don't get confused and think this derivative applies to anything except that. Leave the natural log alone, plus, now I'm gonna leave the x to the 1/2 alone times the derivative of the natural log of x. So, power rule, bring the 1/2 out in front, x goes to the negative 1/2. 1/2 minus 1 is negative 1/2 times natural log of x plus x to the 1/2. And as we reviewed either in the videos or at the start of class, that's just 1 over x. All right, so you all got that. We might have dropped an exponent here and there, but we got it, we found it. And so we've got this, and we could leave it there. And then I saw Jack had it, and I said, hey, Jack, simplify. Jack actually did something kind of cool that I'd like to at least write up here. So this is fine, but what's to follow is better. So this is a negative exponent, and that means it can go underneath the fraction bar times natural log of x. Over here, Jack, did you simplify those guys?
Yeah.
What did you get, my friend?
Well, the square root of x over x.
So square root of x over x, cool. Yeah, so that's good. Let's leave it as x to the 1/2 because we're gonna do one more thing. So can we do anything with this guy? Is there any more simplification? I've got a power of x over a power of x. What do you do with the exponents? What's that?
X of a over b.
A minus b?
Or a minus.
I knew that's what you meant. So I can write that as a subtraction of the exponents, right? So for example, if I had x to the 5th over x squared, that's x to the 5 minus 2, that's just x cubed. So I can do that up here, and I'm going to, this is 1 over 2x to the 1/2. I'll put the natural log on top. I'm doing a little bit each time. Plus, this is x to the negative 1/2, because that's actually x to the 1st down there. So 1/2 minus 1 is negative 1/2. Now I'm going to do what I did to this thing, what Jack did, and put that underneath. So that's actually this. And now I'm going to combine these fractions. These almost look the same, except this one is missing a 2. So I'm going to multiply by 2 over 2. Now I've got a nice common denominator of 2x to the 1/2. On top, I've got natural log of x plus 2. At some point in the future, I would ask you, when is that equal to 0? I will not ask you that today. But to figure out where this thing equals 0, we would need to get it into this form. So this is the ultimate best. Certainly the best looking, the best most useful, so forth and etc. Questions on that at all? This part, you're probably just kind of like, okay, take your word for it. Could do it if I had some time and someone put me under duress. All right, so let's do another one. What is the derivative of e to the x times natural log of x? Simplify as much as possible.
I watched the videos.
You want, okay, cool. But we actually covered one new thing, which is the product rule. I had that up on the board for a long time.
Is that what you put
It's definitely that rhythm, yeah.
I
So.
think I watched the video about that.
Oh, cool. Okay, awesome. So the idea is when you have something times something else, and you can do the derivative of each piece.
Mm-hmm.
They each get a turn at derivatives, and you put pluses between the sharing. So the first one is derivative of the e to the x, leave times natural log of x, leave it alone, plus leave the e to the x alone, times the derivative of natural log. It's a nice, simple rhythm. Yeah?
Yeah.
Okay. Cool. Yeah, it's lovely. I was gonna ask you where it equaled 0, but it can't be solved without a computer, so. See folks using the notation, please do that. Keep your head straight. Math notation is a technology. It's not just writing for the sake of writing. It helps your brain process things. So first I apply the product rule. You might even want to, in your own work, make a note when you use a rule so that if you look at it later, if I look at it later, which could easily happen, you know what happened. You know what your thought process was. Derivative of e to the x is just e to the x. Natural log of x just comes down, plus e to the x. Derivative of natural log of x is 1 over x. That's about it. Is this looking good? One thing I could do here is this. I could factor the e to the x out, natural log of x plus 1 over x. And there's nothing else we can really do with that. Thumbs up? Cool. Thumbs up. Let's do some quotient rules. So there's a new web workup. And it's got, I think, about 10 problems and it's due on Sunday, which I think should work. We'll spend some time on it in class on Wednesday. I will show you one new thing on Wednesday because I need to plant the seed as soon as possible. But let's do some quotient rule stuff. So let's say I have the derivative of 3x squared minus 2x plus 1 over 4x minus 5. Let's do this one together. I have a quotient. I see a big fraction bar and I need to take the derivative. What you wish it was just the derivative of the top over the bottom. And then you remember, oh no, it's not that simple at all. So the quotient rule says take the derivative of the top. I would definitely write this out for the quotient rule. Derivative of the top times the bottom left alone minus So we're getting the product rule field, but we've got a minus in the middle, and I have to do the top first. Minus top left alone times the derivative of the bottom. See how helpful that's going to be to have that all written out like that, because now I've just got, and then the bottom squared. Just copy that down, square it. Now I've got two simpler problems. I just have to find that derivative and that derivative and keep them in parentheses. So when I go through here, actually, hey, could you do this one for me? You should do that. Can you take this home and do any simplifications to the top that will come along? Let's see how simple we can get this thing. This is making sense, Katya. First pass should find you precisely there. Let's see where the first pass is.
It's not there.
Not there? So let me see. So let's look. Okay. So don't multiply these out.
Okay.
You're causing yourself unnecessary grief. That's not going to get you the right thing anyway.
Okay.
So just the derivative of that piece. So look, we got the notation, derivative of that times that. If we wanted both of them, we would have a big parenthesis around. So just think of this thing only works on the thing right to the right of it.
Okay.
So just the derivative of that, copy that down, minus, I copy that down, times the derivative of that.
Okay.
So there's only two derivatives, take that one, and then do a rewrite. So now do you see how I got that? Check out the derivative of 3x squared. Bring the 2 out in front. 3 times 2 is 6. X squared becomes x to the first. So that's where the 6x comes from. The negative 2x, that's that special rule, derivative of a constant times x is just the constant. So it's just minus 2. And then I copied the rest.
Okay.
So do you see how the derivative of 4x minus 5 is 4? Because 4x goes to 4, constant goes to 0.
Yeah.
Now, doesn't that look better than what you're doing?
Yeah,
Yeah.
that's way easier.
So now, Louisa, now you can multiply. So there's no more ddx's, so I'm done with derivatives, I'm done with calc. Now FOIL.
Okay.
Then, and you seem to have the foiling down real good.
All right.
This is a way better.
Okay.
How's it going, Hannah?
Good, I just have a question.
Yes, ma'am.
On this part,
Uh,
was the 3x squared?
Yes.
Why did you drop the 1 if it's not of that part?
Yeah, thank you, this is poorly copied.
Okay.
I did, yeah, I got, hey, thanks, good stuff. Yeah, because I should have just copied that down. You are correct, my friend. Thank you, Hannah. I owe you a power bar or something. I'm sure you could probably just consume those all day. How's it going?
Yeah, I just got to there.
Beautiful. Cool. Where do you go next?
I honestly don't know.
Foil.
So we do foil.
You do foil these two,
Okay.
and then multiply that 4, distribute that 4 across this,
Okay.
then subtract everything from that foil. Take everything over here from whatever you get over here from the foil. Yeah?
Got it.
Cool. How's it going, Kat?
Good.
Yes. Okay, all right. Oh, you're foiling. I see. Lovely, lovely. And the one thing, a lot of people will end up foiling out the denominator. Never do that. Don't waste your time. I've got some crazy foil hungry people in this class. I want them to not foil that bottom ever. We just like that. We just leave it like that. I think that's about as good as we can get it. We could try to factor the top. I don't think it factors, so let's not spend a lot of time on that. It might. I don't know. It doesn't matter. Okay, shit, I gotta try. So I'm just gonna see if I can factor that top out. Pull a 6 out. It's because of that 6 that comes out that makes me feel like maybe. No, can't factor that. Not nicely. Not with any cool.
So you don't want us to do that?
I do not, because to do it's there's nothing we can do that's going to be really sweet on that one, Hannah. Yeah. So if one of these has to be 2x and one of these has to be x, and there's no way to get a -5 on the OI thing. So this is great. I would never give you something and say totally factor it unless it had that.
Could we leave the top as that?
Yes, ma'am.
Okay. That's
Yeah,
what
I would just leave this top alone.
Okay,
Yes,
just leave that one.
exactly. Any other questions on this one? I got one more for you. This one has a combination in it. You're going to need the product rule and the quotient rule. So the notation, going slowly, writing out with notation, everything is going to be absolutely essential here. So what I would like you to please find is the derivative of x cubed times e to the x over x squared plus 1. Write out the quotient rule first. Let's just get there. Write out the quotient rule in its full glory, and then let's talk. Pages flipped, and that sounds good. Pages should be flipped, especially if those formulas are on a different page. Use more parentheses than you've ever used in your life from here on out. Jump onto this pen ages ago. So that's the level 1. All I did was write down the quotient rule. I didn't even think. I'm literally just plugging into the quotient rule. Sometimes thinking about it like this can help. X cubed e to the x in the square, x squared plus 1 into the triangle. Can somebody tell us what has to happen next?
Take the derivative of the top.
Yeah, we've got 2 derivatives to take, right? What about this one, Hannah? How would you read that expression?
The derivative of it, or just?
Yeah, just like, can you just read that to me?
The derivative of the product of x to the, or x cubed to e of x.
Yeah, nice. So product rule. So this one requires the product rule now. So this is a times. So that implies the product rule. So what I would recommend is now to do that derivative inside its own parentheses. Here you're going to put the derivative of x cubed e to the x and write it out again. Use the notation, product rule. It's going to look ugly. It's going to be a lot. notation is keeping us sane. You see how crazy this gets. Might even want to do scratch work. I'll do a little scratch work just to help keep our brains on track. Scratch work will also become your friend. Product rule, just writing that out. Not even doing calculus. Not even doing math. Plugging stuff into a rhythm. That bottom left rhythm. No math has occurred. No calculus has occurred. Calculus is about to occur when I do these things because they're reminding me I still have to do that. That's why I notated it that way. Still haven't done that part of the books. So now I do that part. This is the power rule. Leave that alone. Just copy it down. And then I get really happy because it's the easiest derivative in the world right there. It's just e to the x. So this entire expression goes into those brackets right here. So right here, goes that. And that's literally just that first part. I've still got the rest. I'm going to stop for a second to make sure we're feeling okay. Thumb, I thought I saw thumb go up. Saw thumb go in Jack's mouth. Jack, how do you feel about that?
Good. So you wouldn't try and factor that out?
I would on the next pass.
Okay.
But I would say just like for a while, just one thing at a time.
Okay.
Save the factoring for the end. It's like icing. Yeah. Louisa, does this feel okay?
Yeah. It's just a lot to write down.
It is. It is. Katya, my friend, how's this look?
Good. I was also wondering if we were going to factor it out, but.
Oh, I like that you're so stoked to factor. But let's hold that shit off till the end. Like, just keep this in your brain. Factoring is the icing on the cake. You just gotta bake the damn cake. Not eatable. Not open up a tin of frosting and just start eating it. Not that that sounds bad. Can somebody help me out? What's the derivative of x squared plus 1?
2x.
Ah, nice. Several at once. So times 2x plus 0, right? 2x plus 0 over the bottom. I would never FOIL out the bottom. I'm going to say that about a gajillion times. Just leave it like that. It's pre-factored. You guys should be stoked about it. Pre-factored. Just like you like. It's like your bones are aching for. So now I can do something here. And the thing I'm going to do, there's actually a couple different routes to go. There's actually several different routes to go. Let's see what we can do. So, factoring friends. People jonesing to factor. Give me a factoring to do. There's lots of different ways this could go. Give me one. How about here? What about here? Just right here. What can we do? What could come out of this expression?
An x squared e to the x.
Yeah. So right out of this piece, right, just right here, I can pull that, and then I'm left with 3, because this was 3x squared e to the x. I can just pull that out. I got a 3, and then what am I left with here? X. Lovely. See, that's not so bad. And then I still had that times x squared plus 1. I'm using brackets and braces. It's okay. You can use whichever you prefer. I use these bigger ones when things I think might have more stuff inside of them. And then over here, I'm just going to rewrite this as 2x to the 4th e to the x all over x squared plus 1 squareded. Anything else can happen to the top. So we kind of just factored on this piece. Is there anything in the top that I could pull out of the whole top?
X squared plus 1.
Wait, so that'll be less, so, but this piece doesn't have that.
Okay.
So that's, I bet you're thinking right about, that'll be left. But what do they each, let's talk a minute, Louisa. So I got a product of stuff here, product of stuff here. What's one thing they both have in common? E to the x, definitely. So let's put that out. So let's pull in e to the x. What's the highest power of x that I see in each of them?
Squared.
X squared, there you go. Jack stepped in, gotta get x squared. So now I can pull that out. I think that's about it. So then I'm left with this thing, 3 plus x times x squared plus 1 minus, here I've got that 2 and an x squared all over x squared plus 1 squared. In some ways, calculus started today. We haven't seen things like this yet. There's a lot to do. I'll show you what else we could do. We could FOIL out this and then see if some stuff will simplify in here. And I'm going to do that next. So there's no calculus at this point. I'm just going to FOIL that sucker out. So it's 3x squared. The outer is 3. The inner is x cubed. The last is x. And then I get minus 2x squared. And this is the stuff that makes calc hard. Those rules are just rhythms. It's then pulling together everything you've learned in math to continue working onward. So this is e to the x, x squared. Notice I got a 3x squared minus a 2x squared, so there's just one of those left. Oh, wait, let's put them in power order. X cubed. Then plus x squared, because these two become an x squared, plus x, plus 3. That's lovely, all over this. And I will say with great confidence, we can't do anything with that. I'm pretty damn sure. I'll never ask you to factor a cubic anyway, so don't worry about it. Here's some good news for my web work heavy friends. Folks loaded with web work. Web work would be happy with that. The challenge is getting it into web work, right? Because that could be a bear. You've already got it. But web work's happy at this point. So just keep that in mind. Don't do this stuff. You're going to have enough to do. Don't factor unless it really says you have to. And honestly, the only time you have to factor, here, let me just put this note up here. Final factoring is important only when, I guess the first reason is we're just like aesthetically drawn to that, but that's not a reason enough. When we need to find where the derivative equals 0. And we will have to do that often. So where the derivative equals 0, i.e. solve f prime of x equals 0. Otherwise, don't factor. So in those questions where it's like, where's there a horizontal tangent? So like, i.e. find where there is a horizontal tangent. And that's about what I have for you. So what I would recommend, we have like 10 minutes left. Could you just like open up the web work? The new one, it's derivatives 2. And let's just start on that together. I think we should work on that on Wednesday together too in class so that I can be here for consultation. Yeah, here's a little fun thing, easy thing. This is to make sure folks are watching these videos when they don't show up for class, but you're included in this. Send me an email titled with your favorite color today. I will give you 5 extra credit points on your homework. Or don't, that's cool too. So if you're watching this recording, as you should be, extra credit has to be by, for folks not here today, it has to be by the end of Tuesday, because you should watch this before class on Wednesday. Thanks. Doesn't have to be.
For us too.
Yeah, please.
You said favorite color.
Favorite color in the title. Doesn't even have to say anything in the body of the letter. Give you 5 points on your homework. There we go. Now we got some typing going on. So all of these problems require either the product rule or the quotient, and a few maybe both. So if you're not using one of those rules, something is not it's not gonna work.
What does it mean by differentiate without the product rule?
Oh, okay. Shit. So the first problem says don't do it. Let me see which one that is. That's a good
Well,
question,
it says
Jack.
use the product rule.
Yes.
And it says don't use the product
So
rule.
what they're saying, oh, okay, so in that problem, thanks. That's actually literally freaking problem 1. I'm really glad you said that, Jack. So the only problem where they say don't use the product rule is this. So here's what you should do. Good call, Jack. Really glad we talked about this. So problem 1 on the web work, you've got something like 2x to the 5th times 5x cubed or something like that. One is do the product rule, and they've got little spaces for you to write out the pieces. Then they say do it without the product rule. So what you just need to do is simplify first. So first, then just take derivative of 10, simplify the expression into a simple expression like that. Some number times x to a power. Then just use the power rule. So this one would be 80x to the 7th. Does that make sense? What's that?
The computer just died.
Oh no!
That was your problem.
Well, I guess it's time to stop. You've done enough calculus for one day, apparently. So have we. I'm going to turn this recording off. Remember, friends who are watching this, there's a bonus assignment that you will see. You haven't gotten this far. If you didn't see that shit, you didn't get this far anyway, so whatever.